Hey guys, it's Mrs. Jensko again here. Today we are going to talk a little bit more about the structure of the atom and get into Bohr's model. So we're going to just jump right on in and get and talk about the structure of the atom. I've got a little glare on my screen, it looks like. So here we go. Structure of the atom. We're going to get into the proton first up, okay? The proton is a positively charged particle. Big thing, it is found in the nucleus. It has an atomic mass unit of 1.0073. All protons are identical no matter what atom they come from. And you can see that we have this giant mass of the proton, not giant, very, very tiny mass of the proton. Now, getting to work with such a tiny, tiny number got so clumsy that scientists created a new unit, and that new unit is the atomic mass unit. Okay, it just became easier to work with, and we basically assign the proton a atomic mass unit value of 1, and you can see that here we give it 1.0073. So basically an atomic mass unit of 1. It's just a lot easier to work with instead of all of those zeros that are associated with the kilogram mass of the proton. Onto the neutron. The neutron is no charge, also found in the nucleus, big portion here. All neutrons, again, are identical no matter which ones they come from, and again, very, very small. So AMU 1.0082. So again, just about 1 AMU. The electron, very, very small, negatively charged outside of the nucleus. It is about 2,000 times smaller than the proton and neutron. It's much smaller than the proton and neutron. Okay, so then what we have is we have these charts, and these charts are the ones that you want to get yourself familiar with. Okay, it sums up everything that the previous notes just said. Okay, so the proton, neutron, and electron. Location, nucleus, electron cloud. Mass, 1 AMU, 1 AMU, electron cloud, 1/1836 AMU. Charge, +1, 0, -1. Region of the atom, nucleus, electron cloud. Mass, very large, electron cloud, very small. Size, nucleus is very tiny, electron cloud is very gigantic. In fact, if you want to try to wrap your brain around this, if the nucleus was a golf ball, okay, let's say you've got a golf ball in your hand, and that is the size of your nucleus, okay, you would have to walk 1 mile in each direction. So you'd have to walk 1 mile as your radius. So 2 miles in diameter would be the size of your atom if your nucleus was a golf ball. So you can see that the atom is mostly empty space, okay? And then the charge, nucleus is positive, electron cloud is negative, okay? Electron cloud, space in the nucleus in which the electrons move. In big part here, non-fixed paths. They go wherever they want, okay? Electrons are arranged in energy levels. Lowest energy level is found nearest the nucleus, holds a maximum of 2 electrons. Higher energy levels are further from the nucleus. Big thing here, the electron arrangement gives its chemical properties. So how things are organized will tell you how things are bonding, okay? Electrons in the outermost energy levels is where bonding occurs. So bonding is in the outermost energy levels. Neutral atoms with filled energy levels, so filled will not bond because they're filled. They have their maximum energy levels. It's all about, bonding is all about filling their energy levels. So if they're not quite filled, they will do whatever they can to fill their energy levels. So they'll bond with other people's to play nicely and to fill their energy levels. So if they're already filled, they don't need to play nice with anybody. So they don't bond. Okay, that's the name of the game, is they always want to fill their energy levels out. So they'll bond with other things to fill it out. So if they already are filled, they don't need to bond with anybody and they'll keep it by themselves. All right, so we're going to do Bohr's model. Okay, so we're going to show these electrons in their energy levels. Okay. And what we're going to need to do, we're going to need to use our periodic table. Ooh, yes, periodic table is the first thing that we're going to need to do today. Okay. All right. So we've got some, determine the nucleus, draw protons and neutrons. Determine the number of electrons in the neutral atoms is the same number of protons. Place the first 2 electrons in the first energy level. The next energy level holds 18. And I've got the energy levels in how many electrons they fill, and place all the electrons in their correct energy level. So here's what I've got here. These are the max number of electrons in each energy level. Now, we're not going to go all the way down to the 7th energy level. That's just brutal, okay? So here's what we're going to do. We are going to do calcium and sulfur, okay? So we're going to do calcium. So we're going to go to our periodic table. Ta-da! Here it is. And we're going to do calcium, okay? So we've got calcium right here. First thing we need to do is look at the atomic number to figure out the number of protons and neutrons that we have. And the atomic number is in the upper left-hand corner, okay? And that's a 20, okay? That's going to tell us the number of protons, neutrons, and electrons for us, okay? So we have 20. So we're going to go back to our notes here. And in the middle where you have some space, okay, what you're going to do is you're going to write that 20, okay? And we're going to put 20p and we're going to put 20n, okay? Now, that number of neutrons can change. Sometimes it will be 20. Sometimes it may be 23. That number can change, but if no information is given about the number of neutrons, we're going to assume that protons and neutrons are the same. Also, our number of electrons is also going to be 20. Okay? So that's the first part. Okay? Now what I'm going to do is I'm going to put in my first energy level. So I'm going to put a nice big circle around my first energy level, okay? And now I'm going to go back to my periodic table. And my first energy level is right here up at the top, okay? These numbers down here on the side, these, oh, come back here. Oh, sorry. These are the energy levels. That's why the periodic table is so magnificent. It's arranged so perfectly, okay? And now I count how many elements I have, okay? And I have hydrogen and I have helium. So I have 2 electrons, or I have 2 elements. And I'm going to assume that the elements are like electrons. So if I have 2 elements, I have 2 electrons. So I'm going to go back now to my elements, my calcium here. And I'm going to put in, I want to get rid of that. I don't want to highlight it. I'm going to put in 2 electrons to stand for the hydrogen and helium of the second energy level, of the first energy level, excuse me. Hydrogen and helium are the first energy level, okay? And that's all it can fit. And if you look here, up here at the first energy level, the first energy level can only hold 2 electrons, okay? And that's what I've got, 2 electrons, okay? So now I'm going to go and I'm going to put my second energy level, okay? Go back to the periodic table, second energy level, and the second energy level holds lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And I'm going to go through all the elements until I hit the element of my desire, until I hit calcium. So I just highlighted 8 elements, okay? So I'm going to go back to my drawing here, and I'm going to put in 8 electrons for the 8 elements that I highlighted. Okay, I'm not to calcium yet, and again, you can see the second energy level can only hold 8. Okay, so then I need to go to my third energy level because I'm not towards calcium yet. Okay, back to the periodic table. Okay, so third energy level, and I can hit sodium, magnesium, aluminum, silicon, boron, or phosphorus, sulfur, chlorine, and argon. Okay, that's 8 of them. So back to my drawing. So I can hit 8. Okay, and again, the third energy level can hold 8. And so now I need my fourth energy level, periodic table, fourth energy level. And now I have potassium and calcium, and now I've hit it. And that's as far as I'm going to go because now I have hit the element that I am choosing to draw my Bohr model. So I'm not going to continue through the rest of my fourth energy level. I'm going to stop right there because I've hit the element that I am choosing to draw. So once you've hit the element of your choice, you stop, okay? So I have only hit 2 elements, so all I'm going to put on my fourth element are 2 electrons, okay? So I go back to my calcium, and I only put 2 electrons in it, okay? Now, if you look up here, the fourth energy level can hold 18, but I didn't have 18 elements that I needed to choose. I only needed to choose 2 elements before I hit my element of choice. So that's all you put in there. Yes, it can hold more, but I didn't need it to hold anymore. I was done with where I was at. So I only put what I needed. And that is the Bohr model for calcium. And I'm done. Okay? That's it. That's all you had to do. Okay? Now I'm going to do sulfur. Okay? So I'm going to go to my periodic table, but I'm going to erase what I have here so that we can start all over. Okay? So sulfur is over here, and it is number 16. Okay? So in the middle here, 16 protons, 16 neutrons. My first energy level holds hydrogen and helium. So hydrogen and helium, the 2 of them. That's the first energy level. Now to the second. And it holds lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So I can put all 8 in there. Then to my third energy level, periodic table, and the third energy level holds sodium, magnesium, aluminum, silicon, phosphorus, and sulfur. And I'm at sulfur. I'm done. I'm not going any further than that. So I highlighted 1, 2, 3, 4, 5, 6 red elements. So I'm only going to put 6 dots or 6 X's in my third energy level. Okay. So back here, I'm going to put 1, 2, 3, 4, 5, 6. Ta-da, done. That is sulfur. And that is all we are doing for today. Go ahead, do some practice with Bohr models. Please ask questions as you go along, but you got to have that periodic table sitting next to you. So good luck. Again, ask questions as you need to. So there we go. Start drawing Bohr models.